This is part 13 of 8086 instruction set. You will see some logical instructions. First one is test, which is logical compare. It will do bitwise AND of the source and destination operands, and the result is discarded, but based on the result some status flags are set. So this is the format of test instruction. We have test followed by destination source. So the allowed operand combinations are these, that is, operands can't be both memory locations, then they can't be immediate in the destination, okay, and they can't be both immediates too. So these are the restrictions. Now let's see how test instruction works. So test, as I told earlier, will do AND, logical AND of source and destination. Then the result will be temporarily stored. Now what happens is, based on the result some status flags will be set. So the flags set are the sign flag, the parity flag, and the zero flag. So the sign flag will be set as the MSB of the result, while the zero flag will be set based on the result that we obtain after performing AND of the destination and source. If the result that we got is 0, then zero flag will be set as 1, else zero flag will be set as 0. Then regarding parity, the parity flag will be set based on the parity of the final result. Okay, so if it is even parity, the parity flag will be set. If it is odd parity, the parity flag will be cleared. Okay. Next we have a pair of instructions, SAL, that is shift arithmetic left, and SHL, that is shift logical left. So both of their operations are identical, as it is a left shift. So what they does is, they will shift the given operand or the destination left the count number of times. Okay, and while they shift it, 0 is shifted into the vacant space from the right. Okay, so these are the formats of the instructions. SAL and SHL both have the same format. Followed by the instruction will specify destination followed by the count. Okay, and in case of destination can only be a register or memory location. Now what happens when these bits are shifted out to the left? Okay, so the shifted out bit should be held in CF or the carry flag. And regarding the count, right, which is the second operand, the count can either be 1, which is the immediate value, or the count can be stored in CL register, and CL can be specified as the second operand. Okay. So let's see one example of SAL SHL pair. Suppose that we have this operand in the destination which has to be shifted. Okay, now we are issuing shift left or shift arithmetic left instruction. So what happens is, if you observe this MSB, right, it will be shifted onto carry flag, right, then correspondingly all other bits will be shifted one position to the MSB part, right, and if you see here, 0 will be inserted from the right end. Now this is the current value in the destination. Now if you are performing one more shift, what happens is, the 0, right, which is there in the MSB, which will be shifted into carry flag, then correspondingly other bits will be shifted onto the left, and 0 will be inserted from the right into the LSB. Next instruction is shift right. So in case of right shift instruction, behavior will be different. Okay, we have actually two shift instructions. One is shift logical right and shift arithmetic right. So first we will see shift logical right. So in shift logical right, the destination will be shifted count number of times to the right, with 0 shifted in from the left. Okay, so that's the main thing to note. Whatever vacant spaces are left on the MSB section after the right shift, right, those will be filled by 0. So that is shift logical right. Okay, and one more thing, destination can only be register or memory. And as we have seen earlier, here the shift is going to the right side, right? So the LSB which is just shifted out will be held in carry flag. The count can either be specified as the immediate value 1 or can be kept in CL register. We will see an example of shift logical right operation. So if you see here, this is the operand that has to be shifted. Now one shift instruction is issued. So what happens is this LSB, right, it will be shifted on to carry flag. Then remaining other bits will be shifted towards the LSB section, while on the vacant space, right, which we have on the MSB, it is filled with 0. Then this will be the final value left in the destination. Now once again, if you issue a shift on this final value, what happens is this 0 which is currently occupying the LSB will be shifted onto the carry flag. Similarly, the other bits onto the right section, and one more vacant space will be available in the MSB that will be filled with 0. Now considering SAR instruction, which is shift arithmetic right. So what is special about shift arithmetic right is it performs a right shift while preserving the sign of the current operand in the destination. Okay, so destination is shifted right by the count number of times with the current sign bit shifted in on the left. That is, the current sign bit is the new value being inserted from the left. So its format is exactly like the earlier right shift operations. Destination followed by the count, then destination can only be register or memory. Then as usual, the right shifted bit, the bit that ejects out from the LSB, will be held in carry flag. Then the count you can specify either as the immediate value 1 or can be any value which can be specified in CL register. So let's see an example of shift arithmetic right. So this is the operand that has to be right shifted. Suppose we are right shifting it by one place. What happens is the LSB, right, this one in LSB will be shifted out onto carry flag. Now we have a vacant space in the MSB, but if you note here, the existing MSB is 1. Okay, so that is replicated again. Okay, so the vacant space that was created due to the right shift is filled with the earlier existing MSB. Now this is the current value that we have in destination. Suppose we are right shifting this current value once again. What happens is the 0 in the LSB will be shifted onto the carry flag, and from the MSB section, right, the current MSB is replicated onto the free space. So this is how SAR works.